The displacement time graph of two bodies P and Q are shown in the figure. The ratio of velocities of P to that of Q is. Here in this figure, two bodies are given P and Q, so that when we find out tan 45, we will get opposite side by adjacent side. Opposite side represents distance divided by adjacent side is time. So distance by time, that you will get velocity for the body P. We know that tan 45 is 1. Similarly, we will find out tan 60, that also for the second body. Again, it is opposite side by adjacent, that also d by t. V2 you will get for Q. Tan 60 is root 3. So when you find out tan 45 by tan 60, you will get 1 by root 3. It is actually V1 by V2. So correct option is option B, 1 by root 3. A particle moves along a straight line such that its displacement at any time t is given by tq minus 6t square plus 3t plus 4. The velocity of the particle when it is in equilibrium. Equation for velocity is rate of change of displacement ds by dt or t by dt of tq minus 6 t square plus 3t plus 4. This is of the general form d by dx of x raised to n, that is equal to nx raised to n minus 1. We can apply this one here, so that it is 3 into t square minus 6 into 2t raised to 1 plus 3, or it is 3t square minus 12t plus 3, and acceleration is dv by dt, rate of change of velocity, or d by dt of 3t square minus 12t plus 3, that is 3 into 2t minus 12 in 12. And in equilibrium, when the particle is in equilibrium, force is 0. That means force is ma is 0, which means acceleration, mass cannot be 0, acceleration is 0. That means this one, that is 3 into 2t minus 12 equal to 0, or 6t equal to 12, or t equal to 12 by 6. To substitute this value of t in this equation, so that we will get the velocity. That is velocity equal to this one, that is 3 into t is 2 square minus 12 into 2 plus 3. That is 3 into 4 is 12 minus 24 plus 3, that is minus 9. So correct option is minus 9 meter per second. A body is projected vertically upwards and it returns back to the same point. A velocity time graph of the bodies. When a body is projected up, its velocity goes on decreasing, and at the topmost point velocity becomes 0. When it comes back, that is in the opposite direction, velocity goes on increasing. So here, first in the positive direction, that is upwards, velocity goes on decreasing and comes to 0 value. Then in the opposite direction, this velocity goes on increasing in the negative direction, and it is shown in the graph C. A particle moving along a straight line with a constant acceleration of 4 meter per second square is found to cover a distance of 10 meter in an interval of 1 second during the its motion. The distance covered by the particle in the previous 1 second is distance covered in the nth second. We can write it as u plus a into n minus half. That is u plus a is 4 into n minus half. This is for nth second. So for n minus 1 second, we can write the equation as s equal to u plus a into, instead of n, we will write n minus 1 minus half. That is u plus 4 into, we can split this equation into 2. That is, we can write n minus half, then a into minus 1. That is 4 into minus 1. Minus 4. Or this they have given that 10 meter. So instead of this, we can write 10 meter minus 4. That is 6 meter. Correct option is option D, 6 meter. A construction lift takes off from rest from the ground with a uniform acceleration of 1 meter per second square when it is at a height of 8 meter from the ground. A brick falls off from the lift. The time taken by the brick to reach the ground is. First of all, let us find the velocity of the lift. We can use the equation v square equal to u square plus 2as. Since the lift starts from rest, u equal to 0. So 0 square plus 2 into a is 1, s is 8, so 16, or v equal to root 16, that is 4 meter per second. And this velocity 4 meter per second, it is actually the velocity of the lift, and this velocity of the lift is the initial velocity of the brick because the brick is falling from the lift. So final velocity of the lift becomes the initial velocity of the brick. So in order to find out the time taken by the brick to reach the ground, we can use the equation s equal to ut plus half at square. Since brick is falling down, we can take distance negative, that is minus 8. U is 4 into t, and a we can take as negative acceleration due to gravity. It is minus g, that is minus 9.8 or approximately minus 10. So this will become half 10 t square, or we can write it as minus 8 equal to 40 minus 5 t square, or 5 t square minus 40 minus 8 equal to 0. In order to find out the solution, we can use the mathematical equation minus b plus or minus square root of b square minus 4ac by 2a for finding time. So it is a, b, c. So it is 4 plus or minus square root of 4 square minus 4 into 5 into 8 is minus 8. C is minus 8 divided by 2 into 5. That is 4 plus or minus square root of 16 plus 160 divided by 10. Or we can write this equation as 4 plus or minus square root of 176 divided by 10. Or we can write it as 4 plus or minus root 176. It is approximately 13 divided by 10, and it will become time cannot be negative. So first we can take the value as 4 plus 13 divided by 10, or 17 divided by 10, or it is 1.7. So the correct option is option A, 1.7 seconds.